Welcome back to day 8 of our gravity investigation unit. As I'm thinking about this unit, I'm realizing we are almost done with our activities, and you have learned so much about gravity. We've learned that gravity gets stronger with larger objects, more massive objects like Jupiter and the Sun. We learned that gravity is stronger when you're closer to objects. So gravity on Earth is stronger for us because we're on Earth. We're closer to it than we are to the Sun. You've learned that mass and weight are different things. Weight is the force of gravity pulling you down. Okay? And our weight on different planets is different because gravity on different planets, the gravity on planets is different than here on Earth. And yesterday we learned how satellites stay in orbit. They stay in orbit because, like a cannon, they're launched from a rocket so fast that they're traveling at an orbital speed so that they're falling around the Earth and not falling to the Earth. Gravity's still pulling on them, wanting to pull them down, but as long as they're traveling fast enough, they fall around the Earth. So we've learned a lot about gravity, and now it's your chance to build something that shows what you've learned. So I have down here 7 projects that you can choose from. I only want you to do one of the projects, and I'm giving you lots of choices because I think it's more fun when you have something to choose from. So you will have 2 days to design, build, and test these activities. Each of these have different links. Some of them have videos to them. I'm going to go through the ones that do not have videos. The videos are going to walk you through just like this, so you don't need me to do those again. So here, the straw projectile launcher. This, here I'll click on this now. This, instructions for this, you're going to need 2 straws and a balloon and some tape. And what you'll do here, let me see if I can scroll through this. Here we go, just take a minute for it to load up. This is called Launch It. And you tie right here, you tie some tape around a balloon and a straw. And then you put another straw, and notice here you tape it shut, and so that the air can't get out. You put another straw on top of that, and when you let go of the balloon, all of the air will shoot this straw on top, shoot it out like a projectile. So like we were watching yesterday, that projectile cannon. This is kind of like that, except instead of shooting out a pumpkin, you're shooting out a straw. It shows you over here more information about rockets, because that's what you're making, is a projectile that launches. That's what a rocket is. Okay, so that's, right here, I almost forgot to tell you, Robert Goddard, he created the very first rocket. He's from the United States. NASA has a Goddard Space Center, named after Robert Goddard, the first man to create a rocket. Alright, over here, back to our presentation and to our choices. You can build a rocket out of paper, straw, and tape. So this has all the instructions of how you can do that. If you have those items at home, you can try it out. This one right here, I think, is a fun video to watch, how to do this. You click here, make a paper airplane. It shows you how to make a paper airplane. There's a lot of other ways you can make paper airplanes. So make your favorite style. And then with a rubber band, you can launch it as a projectile, like we were talking about yesterday. So follow the instructions of this video to make that. Oops, let me go back. Here we go. You can make a device to land a rover on Mars. Over here has a video, down here below is a video by NASA showing 3 different ways that NASA has landed vehicles on Mars. Now, no one has traveled to Mars yet, but we've sent several robots robotic rovers, to go over the surface of Mars. And so it has the 3 ways that's done. And then you can, if you click on this instructions here, it gives you some ideas of how you can build your own lander. Now, of course, you don't have to use these things or make it this way, but this gives you some ideas. Using balloons, you'll see those, craft sticks, rubber band, string, cup. It says an egg. I would recommend a marshmallow, or just something, maybe even like a little Lego person right here would do the trick that you put in your cup. and you'll try testing it. So here is an example of one way that NASA lands vehicles on Mars. It has these giant air balloons that make it so that it's a lot cushioned when it hits the ground, so that the rover is not damaged when it first hits the ground at high speed. Other things it does is it uses these rockets here to land, much like the lunar lander that we were playing with earlier in this unit, to slow down the descent. And you can see that in the video that's there. So if you're interested in creating one of those, try that out. This one right here is build a lunar lander. I have the instructions for it. Actually, this is one I did. I'm going to show it to you right now. So this is my lunar lander, and as you can see, it looks just like the ones that landed on the moon, doesn't it? Here's the red part is the cup, and that's the part that has the people. Then I have the base right here. This is just made from a paper plate and plastic cup. You can have a paper cup or something there. And then what the design idea is to make something that will cushion. See how that cushions the landing, so that you don't have a hard landing. Hopefully, have a soft landing. And then inside, I'll show you what I have inside here. I have my two marshmallow astronauts. They're in their spacesuits, white spacesuits there. See that? There we go. So I'll put those back in. They're now in, and I'm going to test this out for you. This will be a successful landing if I drop it from about 30 centimeters or 1 foot here, and if they stay in and they're uninjured. So let's find out. You're going to see if mine works. Ready, set, 3, 2, 1, drop. Oh my, that worked better than it did before. Usually they fall out. You guys just saw a successful landing. Congratulations, my marshmallow people are safe on the moon. And they taste very good. So that's the lunar lander. This one right here, though, probably is my favorite. It's build a lunar rover. NASA, when they went to the moon in the 1970s, they took up a lunar rover for the astronauts to drive around on. So check out this video how you can make one at home. And down here at the bottom, if you are running short of supplies and you don't have any of these things, or can't you don't have anything to substitute them with, I have a virtual rocket you can build. This takes you to a NASA website, and it gives you lots of different designs for rockets. So check that out and see what you can learn about what are all the different parts of rockets by doing that. And remember, just like our title, rockets are projectiles, okay? They're just traveling very, very fast. Now, going to the next day, day 9, I'm giving you 2 days. Whenever we do a build, I always give you at least 2 days to build. Design, build, and test it. And then I always want you to give me feedback. How did it go? What were the results? So since I can't be with you at your house and watch you do this, I want you to tell me how it went. How did your test go? So click on the feedback form here. Which device did you choose to make? What did you select? Why did you select this device? Why did you pick that one? Was it because you wanted to be able to eat a marshmallow? That's why I chose this one. Yummy. What challenges did you have to overcome when you were building it? And in your opinion, was your gravity-defying device successful? Mine was very successful, as you just saw. I can't believe it was. That's the first time it was successful. If you were to build this device again in the future, how would you improve it? And explain how gravity affected the device you tested. Well, in my case, gravity was pushing down, and I had to create a base that would push up slow enough so that my marshmallow people wouldn't fly out at the top. Okay? So that's what I would write right here. And it says, think back to what we've learned in this unit about gravity. What could you do to increase the force of gravity? Remember, what makes gravity stronger? Being closer together and making something more massive, right? More mass, more gravity force. Think back to what we've learned in this unit about gravity. What could you do to decrease the force of gravity? Think about that. I know you can figure that one out. Then let me know how everything's going. Is there anything I can do to help? All right. You guys have a great day. Thanks for listening. I'll talk to you tomorrow. Bye-bye.